All right, it's time for your Friday video. So what I decided to do this week is I'm just going to kind of review you for your test next Wednesday. So it's going to kind of talk you through kind of a few examples of some similar things that we've gone over and what might be on the test. So I'm going to pull my PowerPoint up, I hope. Let's see if we can work it. All right. And we're going to start with inverse functions. So that's the very first thing that we talked about was inverse functions. So that starts in chapter 4. All right, I'm looking to make sure that I'm correct in section 4.1. Okay. Now remember, with inverse functions, the domains and the ranges switch. Okay. So I could do it a couple of several ways. All right. One way is I could give you a particular function and tell you to find me the inverse of that function. So go back and look at your notes. All right, you should have your steps in there. Okay, so you might want to stop, pause the video and go get your steps and make sure that you can follow. So remember what you do. First of all, you're going to solve for x. All right. Now, for most people, it bothers them that they have f of x, but remember, f of x is the same thing as y. So you can replace like f of x or g of x, any of those with y. And then you solve for x. So I've got to isolate this x right here. All right. So I've got to get rid of this minus 1. So how do I get rid of a minus 1? I add 1 to both sides. All right. So that went out there. All right. So those ones right there go out and they just leave me 2x cubed on this side, and I've got y plus 1 on this side. So I had y plus 1 equal 2x cubed. Well, again, I had to get rid of the 2, so I divided both sides by 2. So that left x cubed is y plus 1 divided by 2. Then how do you get rid of a cube? Remember, you have to take the cube root of both sides. So I took the cube root of this side and the cube root of that side. So the cube root of x cubed is just x. And I have the cube root of y plus 1 over 2. All right, so you isolate x. Once you get x by itself, then you literally just switch your x and your y. You switch your domain and your range. So that y turns into an x, and that x turns into a y. So there's your inverse. So the inverse of this function is this function. All right, so you've got several homework examples. So go back and look over those. Some other homeworks that you had was sometimes it'll just give you a list of the points in your function. Remember we said the domains and the ranges switch. So the x's and the y's switch. So the x and the y's literally switch. So the point 2, -1 becomes the point -1, 2. The point 4, 0, the x and y switch, it becomes 0, 4. 5, 3 turns into 3, 5. 7, -2 turns into -2, 7. So make sure that you can find the domains of functions. So go back and look over that homework that you had off of section 4.1. Okay. Now let's go look at some other things that you had. You had logs. Okay. Now remember what we said, logs are another way of writing exponents. So you need to learn this little rule right here, because on your test, I might give you a log and ask you to change it to exponents, or I might give you exponents and let you change it to logs. So if you know this, you can do that. So notice, the base of your log becomes the base of your number. Okay. Notice the thing over here by itself becomes your power. All right. So for instance, log of 3 with the base of 10 is x. So if I change that into an equivalent exponential equation, this 10 base here becomes the base here. Now remember what we said, this thing by itself that's r over here becomes your power. So that's how I knew to let that x become my power and then equals the 3 that's left. Now, there's not a base showing here, but you're supposed to know that natural log means log with the base of e. So anytime you see ln, you can exchange that for a log base e, or when you see log base e, you can exchange it for ln. So I needed to know what my base was. So my base was e here, so my base here is an e. Remember, this thing by itself becomes your power, and then it equals the part that's left. So go back and look over that homework and make sure that you can change log problems to exponentials. But you've also got to be able to go the other way. change the exponentials to logs. So you know you're going to have a log. So remember, this base becomes your base. Okay, and then notice up here, this thing goes beside it. So that's how I knew that the x went beside it. And then notice, this thing, that's this power over here, becomes by itself with logs. So that's the way I knew the order to put them in. So if I memorized it and I can write it on my paper, I can just follow it. Now, e to the y equals 4. Now, I need to change it to a log. So remember, this is the base of your log. So that'd be log with the base of e. Okay, and then notice, what's your power here is by itself over here. So my power here is a y, so it's by itself, and then my remaining part goes there. But then log with the base of e is natural log. So go look back over your homework, all right? And I believe a lot of that came off of section, basically, I think it was 4.3, all right? So in section 4.3 and in section 4.4 is where you did that. Okay, so make sure that you can change from logs to exponentials and exponentials back to logs. Okay, all right, look at what else you've got to be able to do for your test. All right, you've got to be able to solve equations. Let's go look at some well, let's look at this one first. You've got to be able to solve when you have a number to a letter. Okay, so when you have an equation that's got a number to a letter, remember what we said in class, you find the number to the letter, that's what I've got to get by itself. And a lot of times I'll actually circle it on my paper. So I've got to get rid of that 4. Well, how do you get rid of that 4? When you have to subtract 4 from both sides. So when I do that, that leaves me with 2 to the 3 minus x. Remember what we said in class, when you get the number to the letter by itself, that's when you take the natural log of both sides. Because then I've got that rule that says I can take this power, remember, and I can pull it down front. So that's what I did right here. I pulled it down front. Now I'm trying to get x by itself, so I've got several things to get rid of. I've got to get rid of this 3, and I got to get rid of this natural log. Well, this is in a parenthesis, so the natural log is easier to get rid of first. Remember, that means to multiply, and we undo multiplication by division. So that's why I divided both sides by the natural log of 2. So those go out and leaves me 3 minus x. And I've got the natural log of 12 divided by the natural log of 2. Now, how am I going to get rid of this 3? Well, I'm going to have to subtract, but I went ahead and took my calculator and divided the natural log of 12 and got that long decimal number, and divided the natural log of 2, it's a long decimal number, and that came out to be my answer. Okay, let me clear these drawings. All right. So the natural log of 12 divided by the natural log of 2 is this long decimal number. Now to get rid of that 3, I had to subtract 3 from both sides. So 3 minus 3 went out and left me a negative x. Don't lose that negative, a negative x. And then when I subtracted 3 from this number, I just got that 0.5849 number. But I don't want negative x, I want x. So if you multiply this side by a negative 1, then you got to multiply this side by a negative 1. So that's why a negative 1 times that number made it negative, and I just rounded it off. Okay, and I put approximately equal to. All right, look at this one. Now it's a little bit trickier because my number raised to a letter is on the bottom of a fraction. Remember, e is just a number. So I've got to, what have I got to do? What I decided to do was to multiply both sides by that denominator. So if you multiply this side by that denominator, you got to multiply the other side by that denominator. Now, why did I do that? Now, remember, that's like over 1. So that means that that one divides out with that one and just leaves me 119 on this side. And then I've got 7 times that over here. So I just distributed it. 7 times e to the 6x is 7e to the 6x minus, and then 7 times 14 gave me 98. So again, remember, I'm trying to get this thing by itself. So I've got to get rid of this minus 98. So I added 98 to both sides. So 119 plus 98 gave me 217. And then the 98s went out over here and just left me the 7e to the 6x. So how do I get rid of that 7? I had to divide both sides by 7. So those 7s went out and left me e to the 6x. And then 217 divided by 7 is 31. Now, remember, when we finally get the number raised to the letter by itself, that's when we take the natural log of both sides. Then I can take my power and I can pull it down front, which is what I did right here. Then remember, I want to get 6x by itself. So, but remember, the natural log of e, that's just 1. And 1 times 6x is just 6x. So I didn't even have to divide both sides by anything. Well, the natural log of 31, I typed in my calculator and got that decimal number. And then I divided both sides by 6 and got x, and I just rounded that answer off. So make sure that you go back and look over that homework where you were solving equations that had e's in them. Okay, so I'm kind of looking through your book, and it looks like those were mostly out of section 4.5. So make sure that you do go back and look over those homework problems where you're just solving for a number raised to a letter. So the letter that you're trying to get, the variable you're trying to solve for is a power. All right. Now look at some other things that might be on your test. All right. We did this today with systems of equations, but I just want to reiterate it. You can use substitution or elimination. I'm not going to tell you how. I'm just going to say solve the system. So you can solve it any way you want to. But like you saw today, elimination is usually quicker. So I can either turn these into opposites or these into opposites. And it seemed to be easier to turn these into opposites because remember, there's an understood 1 there. So if this is 2, I can multiply everything down here by a negative 2 times all of that, and I can make these opposites. So a negative 2 times x is a negative 2x, and a negative 2 times 4y is a negative 8y, and a negative 2 times 10 is a negative 20. So remember, once you get the x's opposites or the y's opposite, you add the equation. So my x's go out, and a negative 3y plus a negative 8y gave me a negative 11y. And then 8 plus a negative 20 is a negative 12. So to get y by itself, I divided both sides by a negative 11, and y came out to be positive 12 over 11 because a negative divided by negative is a positive. Then remember, to get the other part, you've got to plug 12 11ths in for y in this equation or that equation. It doesn't matter which one. I just used the bottom one because it looked simpler. So I took that y and put 12 11ths in place of it. Okay, now remember, that's like that 4 is over a 1. So 4 times 12 gave me 48, and 1 times 11 was 11. So I'm trying to solve for x. So I had to subtract 48 11ths from both sides. So those went out and just left me x. Remember, that's like 10 over 1. But now when you're adding and subtracting, you have to have a common denominator. So my common denominator was 11. So what do you multiply 1 by to get 11? Don't you multiply it by 11? So 10 times 11 is 110. So my common denominator of 11 stayed, and then 110 minus 48 gave me 62. So there's my answer. X is 62 11ths and y is 12 11ths. Now on your test, what I might ask you to do is I might ask you to graph it and see if this answer looks right. So do you realize this is a line? Let me kind of clear the drawings. This is a line and this is a line. So you got 2 lines that are going to cross at the point 62 11ths, comma 12 11ths. Now, how did I know what order to put them in? Because remember, this is my x and this is my y. Now, 62 11ths is about 5 and 7 11ths, and 12 11ths is about 1 and 1 11ths. So if you draw these 2 equations, these 2 lines, you're going to have intersecting lines that are going to cross right at that point. So you can see if it looks like it's right. You can also substitute both of these into both equations and make sure both equations are true. So you should know before you turn your paper in whether your system is correct or not. But when you get an X and a Y answer, and I ask you, what kind of lines do you have? you have intersecting lines. Now, this is one of those strange ones. I multiplied this top by -3 to make my x's match. All right, so I multiplied everything on the top by -3. So that gave me a -12x, that gave me a -3y, and that gave me a -30. But when I added them, the x's and the y's both went out. So I got a 0 on that side and I got a 35 on that side. Now, there's nothing to solve. When is 0 ever going to equal 35? Never. So there's no solution. That would be your answer. No solution. And if I asked you what kind of lines are they, they're parallel. That means there's no point that's the same on this line as it is on that line. And again, I might ask you to graph the lines so you can see that, yeah, they do look parallel. So make sure that you go back and look over those systems of equations off of 5.1, chapter 5, sections 1 and 2. Okay, so make sure that you go back and look over all of that. And then the last thing you might have are word problems. Now, one of the word problems you might have is like continuous compounding. So you're going to need to know this formula. So make sure that you learn that formula for continuous compounding. And look in your notes. Remember, P is your beginning amount of money and A is your end amount of money. R is your interest rate per year and T is your time in years. So make sure that you learn that formula. So look, if you invest $1,000 at 3 4/10% compounded continuously, how much will be in the account in 5 years? So it's real important that I know whether this 1,000 is my beginning amount or my end amount. So do you see it's my beginning amount? So I plugged it in for P. Because the question might say, how much money must you put in an account to have $5,000 or to have $1,000 in 5 years? Then it would be the end amount. So make sure you notice whether this number is the beginning amount or the end amount so you put it in the right place. Then my interest rate was 3.4%. It doesn't say, so it must be per year, but I had to change that to a decimal. And then my time was 5 years. So then I multiplied those two numbers and got 0.17. Then, you know, you have to do powers before you multiply. You've got to follow that order of operations. So when I took E and raised it to that power on my calculator, I got that number. And when I said that times 1,000, I rounded it off to the nearest penny because it's money. So go back and look over those problems on continuous compounding, because sometimes you're missing the A, sometimes you're missing the P, you might even be missing the T, but I think mostly your problems were missing the A and the P. Then you had several word problems where you had numbers raised to letters, where you were modeling. So make sure you go back and look over all of those, like this one. The population of a town is modeled by P equals 4,500 times E raised to that power, where T represents the year with T equals 0 representing the year 1990. So do you understand that P is your population? It tells you how many people are in the town, and T is telling you what year. But you don't really plug in like 1990. It said if the year was 1990, it wants you to plug in 0 for the year. So I'm asking you, how many people are going to be in this town in 2025? So do you understand? I'm looking for P, so that means I've got to be able to plug in a T. So I've got to know in 2025, what is T? Well, T was 0 in 1990. So how many years later is 2025? Isn't 2025 35 years after 1990? So that's why I put T to be 35. Because if T is 0 is 1990, then 35 would be 2025. And then again, I multiplied those two numbers and got that decimal. I took E and raised it to that power and got that number, because you do powers before you multiply. And then I just rounded it off to the nearest whole number, because you can't have part of a person. Okay. So that's kind of a quick zip through for your test. And your homework assignment is just to start studying for your test. Now your test is Wednesday, but we're not going to spend a lot of time reviewing on Monday. I'll let you take a few minutes to answer any questions that you have. So look back on Moodle, look at your old homework and make sure that you've studied. Okay, so check Moodle and look at your old homework. We'll spend about 10 or 15 minutes answering your questions on Monday. Then we're going to start reviewing for your final exam. So we're going to kind of go back on Monday and review test material 1 for your final exam. And then we're going to take your third test on this material from this video and from what you've had on Wednesday. So if you need anything, let me know, and I will see you on Monday. Y'all stay safe.